Hello friends, today's question. A uniform rectangular thin sheet ABCD of mass M has length A and breadth B as shown in figure. If the shaded portion HBGO is cut off, the coordinates of center of mass of the remaining portion will be. So we have four options and it says, this is the figure. So this is basically divided into four pieces and one of the piece, that is HBO, that is shaded region, is removed. So we have to find out what will be the center of mass of the remaining portion. Okay, let us suppose this is x-axis and this is y-axis. So we can say this F point will be a by 2 and E point will be a by 2 and 0, and this E point will be our 0 and B by 2. Therefore we can also say that G will be equal to A, and we have this B by 2, and H we are going to get this as A by 2 and B, and the O coordinate, which is the, you can say, center of gravity for this entire sheet, is given by A by 2 and B by 2. So it is given that the initial mass of the entire sheet is given as capital M. You can say initial mass of sheet ABCD is given as capital M, and it is being divided into four parts. So each part is going to have a mass of, you can say, M by 4. This sheet ABCD is divided into 4 equal parts. So if it divided into 4 equal parts, you can say that mass of each part will be equal to 1 by 4 multiplied by total mass, which comes equal to M by 4. Now we are only interested in, you can say, find out the, first of all, let's, you can say, find out the center of mass of this, the portion which is being cut out, and then we can use the standard formula for calculating the center of mass for the remaining portion. So considering sheet HBGO, this is your X and this is your Y, and let us draw an enlarged version of HBO. So this point is H, this is B, G and O. Now the coordinates which are given to us, O is given, O is our A by 2 and B by 2. Similarly G is also given, that is A and B by 2. B is given as A comma B, and we have H is also given as A by 2 and B. Let us find out this coordinate, which will be its center of mass for the removed portion. So we have, this is our A by 2, This portion is our A, this is our B by 2, and this is our B. So here we can use, you can say, midpoint formula in order to calculate the coordinates. So we are interested in finding out the coordinate of this point and coordinate of this. So we can use midpoint formula. So if we have a straight line, the coordinate is x1 y1 and x2 y2. Okay. Then the center for this center of this line by midpoint formula will be given as, let us suppose that point is given as m. So we can say m is equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So same formula we are going to use in order to find out the center of all the respective lines. First we are interested in OG. You can say for line OG, its x coordinate the midpoint will be given as a by 2 plus a divided by 2, and which will be coming as 3a by 4. And we can say for line BH, for line BH, its y coordinate the midpoint will be equal to b by 2 plus b divided by 2, which will be also equal to 3b by 4. So we got the respective coordinates. Therefore, let me draw it again here. This was our HBGO. Sorry, so this will be OH, not BH. So we found out these two coordinates. So this will be our center coordinate, will be our 3a by 4 and 3b by 4. Rest of coordinates we already know, h, b and og, the coordinates are given to us. So therefore we can say the coordinate of center of mass for the region HBGO, which is nothing but shaded region, this will be equal to 3a by 4 and 3b by 4. Now we can use the standard formula for center of mass. So let us find out first of all in x direction, x coordinate as well as y. You can say center of mass for x, which can be written as XCOM. This will be equal to m1 x1 plus m2 x2 divided by m1 plus x2. Here we have to write it minus because we are going to remove it, so let me put it minus directly here. Therefore we get x center of mass will be equal to m multiplied by a by 2 minus m by 4, that is a removed portion, and its x coordinate is 3a by 4, divided by m plus m by 4, minus, and this will be equal to ma by 2 minus 3ma by 16 divided by, this will be 3m by 4. So we can say x coordinate of center of mass will be equal to 5ma divided by 16 multiplied by 4 divided by 3m. M and m goes and this goes by 4. Here we get XCOM will be equal to 5a divided by 12. So we get x coordinate. Similarly, you can say the center of mass y coordinate, center of mass for y, say it is y center of mass, formula remains same, m1 x1 minus m2 x2 divided by m1 minus m2. We substitute the values. Y center of mass is equal to m1 is our m multiplied by p by 2 minus m by 4 multiplied by x2 was our same 3b by 4, 3b by 4, yeah, and this we get m minus m by 4. So this will be also coming same. This will be 5b by 12. Therefore, the coordinate of center of mass the coordinates of center of mass will be given as XCOM and YCOM, which will be equal to 5a by 12 minus, comma 5b by 12. And from the option available, you can say that option B is the correct option. Option B is correct. So this completes the question. Thank you.